the section 7.1 lesson video for physical science, and as always, if you want my videos for the whole year in one spot, then just subscribe to my channel. So chapter 7 is about chemical reactions, so let's jump in. So in a chemical reaction, the substances that undergo change are called reactants, and the new substances formed as a result of that change are called products. So when you're looking at a reaction, you will see an arrow, which is referred to as our yield sign. Anything on the left of the arrow are the reactants. That's what we start with. Anything on the right of the arrow is the products, and that's what we end with. So a lot of people get these backwards, so make sure reactants react to produce products. Like, you don't start with a product. That's what you're going to end with, your final product. So reactants on the left, products on the right. A chemical equation is a representation of a chemical reaction in which the reactants and products are expressed in formulas. So instead of saying things like water and sodium chloride, it would be H2O plus NaCl. So we're going to use formulas. The law of conservation of mass states that mass is neither created nor destroyed in a chemical reaction. So in other words, whatever mass you start with, you must end with that same mass. You can't make any more than you start with. You can't lose any. Now sometimes it can appear that you lose some if, for example, you release a gas in your reaction. That gas has mass, and so if it leaves your beaker or flask or whatever you have it in, it will appear to have lost mass, but it didn't actually, like, we didn't destroy mass, the mass just went somewhere else in that case. So how do we make sure that our mass is conserved? Well, that's something called balancing equations. So in order to show that mass is conserved during a reaction, a chemical equation must be balanced. So how do we do this? You can balance a chemical equation by changing the coefficients, which are the numbers that appear before the formulas. And we'll look at some of these in just a second. As you balance equations, you should never change the subscripts. Okay, and so again, when we look at some, I'll talk about what the difference is in a coefficient and a subscript. So here's an example. Okay, subscripts are the tiny numbers at the bottom, so like H2O. That 2 right there is a subscript. Coefficients are large numbers that we place in front of the formulas. So these big 2's, those are coefficients. We can put coefficients to help balance an equation. We cannot change or add or take away subscripts. Okay, so for example, if this is what we have to begin with, we have no choice but to keep the subscripts the way they are. We can only put numbers in front. Okay, so let's look at how this happens. Now, some teachers, they teach you this chart way of doing it. I personally don't like that way because I think it's a lot of extra time in writing that I don't want to do. I just do back and forth method. However, if you've learned the chart method before, or if you learn it in another video and you like that way better, you're more than welcome to do it. I just prefer not to do it that way. So let's look at how I would do it. So it says balance the following equations. So there's some hints that you'll find that I'll teach you as we go through different ones, especially in class, so they probably won't all be on this video. And one of the hints is to save hydrogen and oxygen for last. Like, I like to balance all the other elements first and then do hydrogen and then do oxygen. Now, does that always make it easier? No, but a lot of times it will, especially with oxygen. You'll find that oxygen messes up so many of them. All right, so let's look at copper, Cu. So right now I have 1 right here on this side, on my reactant side, and I have 1 on this side. Because that's the whole thing about balancing equations, is we need the same number of elements on both sides of the yield sign. Alright, so copper is good to go. So then I look at oxygen. I have 2 right here, but here I only have 1. So I can't put a subscript. As nice as that would be, it would make balancing way easier. I can't do that. I can only put a coefficient. So I'm going to put a 2 there. So see, now I have 2 O's and 2 O's. But now I've messed up copper because I have 2 coppers now. So that means I need to go back over here and put another 2. Okay, so see, now I have 2 coppers, 2 coppers. I have 2 O's and 2 O's. So what I want you to notice is a coefficient will distribute to anything written right after it in that same formula. Okay, so we have 2 Cu's and 2 O's. Alright, so let's look at another one. So again, I could do H first, but because I always like to save hydrogen and oxygen for last, I'm going to do Cl first. So here I have 2 Cl's. Here I just have 1. So again, I can't put a little 2 here. I can put a big 2 in front. So see, now I have 2 Cl's, 2 Cl's. and now I'm going to look at H. So I have 2 H's and 2 H's, and so we're balanced. Now, are all of them that easy? Obviously not. Okay, we'll work through some more difficult ones in class as we do some practice. All right, so let's look at our bottom one. So for hydrogen, I have 2 hydrogens right here, and here I also have 2 hydrogens. So hydrogen's good to go. For oxygen, I have 2 right here, but on this side I have 3, because if you look, I have 1 right here plus 2 more. So I have 3 oxygens. Now when that happens, when you have an odd number on one side and an even number on the other side, what I always like to do is just double the odd one, because if you double any odd number, that will make it even. Okay, so who's the odd oxygen? So here we have O2, here we just have O, and here we have O2. So this is the odd one. So what I'm going to do is I'm going to put a 2 in front, because see how now that means I have 2 oxygens, so now it's a nice even number. But before I look at oxygen, I have now messed up hydrogen. That's the thing you have to remember, is once you balance an element, if you then put something in front of it, you need to rebalance it before you move on. Alright, so let's look at what I have now. So here I have 2 H's, but here, whenever you have a coefficient and a subscript, you just multiply them. So here I have 4 H's, and here I only have 2. So what could I put in front to make that 4? Well, 2 times 2 is 4. So if I put a 2 in front, then see I have 4 hydrogens and 4 hydrogens. So we're back on board with hydrogen. It's nice and balanced. Alright, so now let's look back at oxygen. So remember, those coefficients, they distribute. So I have 4 oxygens on that side, and then here I have 2 oxygens plus 2 more oxygens, which is 4 oxygens. So now it's balanced. So that doubling the odd ones, that's a trick that the sooner you learn, the easier this is going to be. Okay, if you have an oddball, just put a 2 in front of it to make it even, and then try to get it fixed from there. Alright, so maybe pause the video and try these 2, and then we'll look at them together. So let's look at our first one. So we have Mg, one of them, and we have 1 Mg, so that's perfect. Alright, we have 1 Cl, but here I have 2 Cls. So I need to put a 2 over here. So see, now I have 2 Cls, 2 Cls. And then last, I have 2 hydrogens and 2 hydrogens. So hopefully you got that one right. Alright, so if you didn't try the first one, pause it and try this one, and then we'll look at it together. So it says we have 2 C's here, and here I just have 1 C. So I'm going to put a 2 in front. Alright, and then we have 4 H's here, but here I only have 2. So what times 2 will make 4? A 2. So see, now I have 4 hydrogens, 4 hydrogens. And then last is oxygen. So I have 2 oxygens. Here I have 2 times 2, which is 4 oxygens, plus 2 more oxygens. You've got to make sure to distribute. Remember, it goes to both. So this goes to this one and this one. So like putting a 2 in front of H2O means 4 H's, 2 O's. So if you look, I have 4 O's plus 2 O's. So 4 plus 2 is 6. So what times 2 will give me 6? A 3. So see, then I have 6 O's, and then 4 plus 2 O's, which is 6 O's. Alright, so hopefully you got one or both of those right. So here are some of my hints for balancing equations. They're hints, not rules, so you don't have to follow them. Sometimes they make it easier, sometimes it really makes no difference. So like I told you already, I like to balance hydrogen and oxygen for last. Another thing that I didn't get to show you in this lesson video because it just hasn't come up yet is if I see a polyatomic ion, like remember, you'll have a chart that has them, like SO4 or PO4 or OH. If I can keep that together, I will. And so again, if there's no examples in this lesson in my PowerPoint, then I'll do a separate video on that. If you have an odd number, like the one we had just a few minutes ago where we had 2 on one side and 3 on the other side, you can multiply the odd one by 2 to make it even, and then usually that'll help the rest of it kind of work out. So because chemical reactions often involve large numbers of small particles, chemists use a counting unit called the mole to measure amounts of substances. So 1 mole is 6.02 times 10 to the 23 particles. This number is called Avogadro's number. So like at the store, when we go buy eggs, we buy them by the dozen. 1 dozen is 12 eggs. Well, 1 mole of particles is just 6.02 times 10 to the 23 particles. The reason this is such a large number, because if it's times 10 to the 23, what that means is it's 602 and then 21 more zeros. So this number is gigantic. But even though it's so big, for a lot of substances, I can hold a mole in the palm of my hand, depending on what it is. And that's because atoms and molecules are just so tiny. So since we have to use such large numbers, we use 1 mole instead of having to use large numbers like this all the time. So, section assessment. What is the law of conservation of mass? Well, law of conservation of mass says that in any chemical and physical processes, mass cannot be created nor destroyed. It can't be created nor destroyed. So number 2, why does a chemical equation need to be balanced? Well, that relates back to number 1, because we have to follow the law of conservation of mass. We have to follow the law of conservation of mass. Number 3, why do chemists use the mole as a counting unit? Well, remember, atoms are super, super tiny, so we're using a lot of particles all at the same time. Okay, so we just use very large numbers of particles, so that's why we use the mole. Number 4, is the following equation balanced? So let's check. Okay, well I have 2 Na, 2 sodium, I have 2 Na, I have 2 Cl, and I have 2 Cl. Don't forget that 2 will distribute. 2 Nas, 2 Cls. So the answer would be yes. Yes, it is balanced. Number 5 and 6, balance the following equations. So again, if you haven't paused it and tried these on your own, y'all, the only way to learn to balance is to do them on your own. You can watch me do a million of them and it won't help you at all. You gotta be able to do them on your own. All right, so pause it, try it, and we'll look at it together. So I have 1K, 1K, 2 BRs, and only 1 BR. So I'm gonna put a 2. But now I have 2 Ks, so I need to put a 2 here. So see, I have 2K, 2K, 2 BR, 2 BR. All right, so hopefully you got that one right. All right, so let's look at the next one. So I have 1 mg, 2 O's, 1 O, so I need a 2 here. But now I have 2 mg's, so I'll put a 2 here. And so if you look, we have 2 mg, 2 mg, 2 O's, and 2 O's. Now again, does balancing equations get harder than what I've shown you in this lesson video? Yes, it does, but that's why we practice in class, so that you can see the more difficult ones. The ones we did in this video would all be considered the level easy. Alright, so hopefully now you understand a little bit more about reactants versus products, the law of conservation of mass, and how to balance easy chemical equations.